Good morning, students. Welcome to Bindu Dhadwal chemistry lessons. Yesterday we did the basic steps of metallurgy. Today we will discuss the first two steps in details. The first step is crushing and grinding of the ore. So the ore occurs in nature as huge lumps. These lumps are broken to small pieces and then later on powdered with the help of ball mill or stamp mill. The process of conversion into powder is called pulverization. After the ore is powdered, the second step is concentration of ore. It is also called ore dressing or ore benefaction. This ore is cleaned, the gangue or matrix is removed, and the process is called concentration. So we can use different methods for concentration of ore. First is hand picking. In this process, some of the ore is simply clarified by picking it by hand and then breaking away the adherent rocky material with a hammer. Then we can also use gravity separation or levitation method. This method is used for those ores in which there is a difference in the specific gravity of ore and the gangue particles or impurities. So this method is known as gravity separation method. The process by which lighter earthy particles are removed from heavier ore particles by washing with water is called hydraulic washing. So powdered ore is fed into a stream of running water when the lighter impurities are washed away and the heavier are left behind. But at small scale it can be done simply, but when it has to be done in bulk, then two major processes can be used. One is wilfley washing and the other one is hydraulic washing. In wilfley washing, a wilfley table is used for separating the gangue from the ore. So powdered ore is mixed with water and then run through this wilfley table. Wilfley table consists of a slanting floor on which long wooden strips called riffles or cleats are fixed. So these are the cleats and the floor is slanting. The powdered ore mixed with water is introduced at one end of the table, and this table is continuously rocked. It moves in a rocking motion left to right. So heavier ore particles will be obstructed by the riffles and will stay here, whereas the lighter ore particles will wash away with the water. This stuck ore particles, because of rocking motion of the table, they move towards the side and can be later collected from here. So this is the concentrated ore. Native gold ore or cassiterite ore is concentrated using wilfley washing table. Second method is hydraulic washing. Hydraulic classifiers are used. A hydraulic classifier consists of a large conical reservoir fitted with an ore inlet at the top. This is conical reservoir, ore inlet at the top and a water inlet at the bottom. There is an outlet for removal of gangue at near the right hand side of the top portion of this classifier, and concentrated ore can be removed from an outlet at the bottom. There is the powdered ore is dropped from the top and water is introduced or forced through the pipe at the bottom of the reservoir. The lighter gangue particles are carried up by the current of water and pass out along with the water. Gangue particles move out with the water. The heavier particles get collected at the base and can be removed from this outlet for concentrated ore. The conical shape helps in reducing the velocity of water and thus prevents the ore particles from being carried away along with the water. Electromagnetic separation process. In this process, a conveyor belt is used, which is rolling on two wheels. One of the wheel is magnetic in nature. This ore moves towards this side, and as it reaches the other end, the magnetic ore is attracted by the magnet and falls nearer to the roller, whereas the non-magnetic impurities form a separate heap because they fall at the further end of the roller. Same principle we can also do electrostatic concentration. In this case, the ore will be one which can be charged using electrostatic field. A thin layer is formed, and when it falls, the ore which is charged is repelled by the electrostatic field and falls further off, whereas the other ore falls naturally down and forms separate heaps. So this method is called electrostatic concentration. This method is used for concentration of lead sulfide and zinc sulfide ores occurring together in nature. Froth floatation method. This method is based on the principle of difference in the wetting properties of the ore and gangue particles with water and oil. The method has been used for concentration of sulfide ores such as galena, zinc blende, copper pyrite. So be sure, if the ore is a sulfide ore, the method used will be froth flotation process. The sulfide ores are preferentially wetted by oil and the gangue particles by the water. The powdered ore is mixed with oil and water. The collectors that are used are pine oil, eucalyptus oil, xanthates. These enhance the non-wettability of mineral particles, so the mineral particles will not get wetted with water. Instead, they get wetted with oil. And when a paddle, rotating paddle, is moved over here, it draws in air and stirs the pulp. Because of stirring, the oil and air mix together and form froth. The sulfide ore sticks to the froth and forms a separate layer at the top, whereas the heavier impurities remain at the bottom of the tank. This froth is skimmed over or taken over to another chamber where it later settles down and is purified. Sometimes, if the ore is a mixture of two sulfide salts, then we can use some depressants to separate them from each other. For example, the ore of zinc sulfide comes attached with lead sulfide. To separate the two, we use depressants such as sodium cyanide. So when sodium cyanide is mixed with the sulfide ore, zinc sulfide forms a soluble complex sodium tetracyanozincate. This forms a thin layer on the surface of zinc sulfide. So zinc sulfide is not able to form the froth. So sodium cyanide acts as a depressant. But lead sulfide comes up with the froth, so the two ores are separated. Leaching. It is a chemical method of concentration and is useful in case the ore is soluble in a suitable solvent. So in this method, the powdered ore is treated with certain reagent which can selectively dissolve the ore but not the impurities. It is used in concentrating ores of aluminium, silver, gold, etc. Let's do leaching of alumina from bauxite ore. Pure alumina is obtained from bauxite by the leaching process which is called Bayer's process. So concentration is carried out by digesting the powdered ore with a concentrated solution of sodium hydroxide at 473 to 523 Kelvin temperature and 35 to 36 bar pressure. The alumina will dissolve in sodium hydroxide, forming a soluble solution, whereas the impurities will not dissolve. So these can be filtered. So impurities remain at the top, whereas soluble sodium aluminate is present in the solution. Also, if silica is present, it also forms a soluble part of the solution. Then the pH of the sodium aluminate is changed by passing carbon dioxide. It is agitated for 2 to 3 hours with carbon dioxide. When alumina gets precipitated, hydrated alumina is separated by filtration. This alumina is then heated to 1470 Kelvin to get purified alumina, and the process is known as Beer's process. We can also do leaching of silver and gold ore. So ore containing native metal, either gold or silver, is treated with dilute solution 0.5% of sodium or potassium cyanide in the presence of atmospheric oxygen. So gold gets oxidized or silver gets oxidized, and then it dissolves to form a sodium dicyanoargentate complex. Filter this to remove the impurities, and then we treat it with zinc. So zinc replaces silver and the silver is taken out. So this process is called cyanide process or MacArthur Forest cyanide process. In the same manner, gold can also be purified. That's all in today's video. Thank you. Have a nice day. If you like the video, please do share and subscribe. Thank you.